Alright everybody, welcome to the day 2 notes on special right triangles. This stuff might seem complicated, so I need you to focus, make sure you know what you're doing, make sure you're finding places to ask questions, put a star or an asterisk by something, and we'll come back and answer those later. So we're going to talk about two specific kinds of special right triangles today. That is the 45-45-90 triangle, right here, and then the 30-60-90 triangle. There's two very specific triangles with some very specific facts, rules, and things like that about them. So going over things we know. You may have noticed in previous days' homework that we had a couple problems where we had like a 7 here and a 7 here. And we do the whole problem and we find out that the hypotenuse ends up equaling 7 square root of 2. Well, that's not a coincidence. That works that way every time. Okay, the hypotenuse is square root of 2 times the length of the leg every time. So that's the square root of 2. Hypotenuse equals square root of 2 times leg. If the leg is 10, then the hypotenuse is very simply 10 times the square root of 2. That's all you have to do. So take a look here, filling in the blank. Let's see. Hypotenuse equals blank times the leg. So this is straight from the theorem. That's what we just did. So it's square root of 2 times the leg. In this case, it's square root of 2 times, it tells us the leg length is 5 times square root of 3. Here, commutative property multiplication, we're going to rearrange this a little bit. This, we're going to say, we're going to put our 5 out here, and then I'm going to put square root of 2 times square root of 3 right here. 5 comes straight down, and when we multiply two radicals like this, it's just what's underneath. So that's 5 radical 6. It's just that easy. Okay? You just got to remember, hypotenuse equals square root of 2 times the leg. Now, here, the length of a hypotenuse is 45-45-90 is 10. What's the length of one leg? So this is sort of like that, except for working in a little bit of the opposite direction. First, we need to know this. Will the length of the leg be greater than or less than 10? And explain. And hopefully your answer there is that the length of the leg will be less than, because the hypotenuse has to be the longest side. Has to. Okay? So the answer here is going to be less than 10. We use that just to kind of give ourselves a reference point. If I get something bigger than 10, I've done something wrong. So if hypotenuse equals square root of 2 times the leg, on this problem, we're saying that the hypotenuse is 10. Okay? Here, we're just going to start solving for the leg. So I divide both sides by square root of 2. Here I'm going to simplify it. Those divide to 1, so all I have now left is leg equals 10 over square root of 2. We're not allowed to have a radical on the denominator of a fraction. So I have 10 square root of 2 times square root of 2 over 2. This is how we rationalize a fraction. Then, up top now, I just have 10 times square root of 2. The bottom became 2 because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. And then we're going to divide that 10 by 2, just the 10, and I get 5 square roots of 2, and it is really just that simple. Some folks want a chart to sort of organize their thoughts, so here's a chart that works. The chart works like this. It sets up 3 equivalent fractions. Okay, this part of the chart is always the same. These are the angles, and these represent the ratios of the legs across from those angles. So we're saying 1 over something equals 1 over something equals square root of 2 over something. And I'll show you how we use that right here. So for example, on this problem, we could set up this chart. Okay, we have 45, 45, 90. And we have 1, 1, square root of 2. And we could set it up twice because it's the same chart for both of them. Okay, because these are both 45, 45, 90 triangles. Okay, so now I'm going to fill in the chart. On this triangle, across from the 45 is a 20, across from the other 45 is an x, and across from the hypotenuse, the 90, is y. Okay. Here, on this one, I'll set this one up at the same time. Across from 45 is y. This one doesn't have anything, but it really could just be y because it's an isosceles right triangle. And then across from the 90 is 18. So now we're going to use these to solve the problem. Again, what we've done is we've set up 3 equivalent equations. So I can say that 1 over 20 equals 1 over x. Well, if 1 over 20 equals 1 over x, then x has to equal 20. No problem. I can also say that 1 over 20 equals square root of 2 over y. 1 over 20 equals square root of 2 over y, and then I can just cross multiply. Y times 1 is y. 20 times square root of 2 is just 20 times the square root of 2. And there's my answers. No problem. It gets a little bit more complicated when we have to find the hypotenuse, only because we're going to have to rationalize the denominator. So the y is what we're looking for. So 1 over y equals the square root of 2 over 18. 18 times 1 is 18. And this is y times the square root of 2. I'm going to divide both sides by square root of 2, and I get 18 over square root of 2 equals y. And then I'm going to rationalize this denominator by multiplying the top and bottom by the bottom. Okay? And what I get is 18 times the square root of 2 over 2 equals y. And then in the last step, I just have to divide, and I'm done. Y equals 9 times the square root of 2. Okay? Couple steps to it, sure, but difficult? Not really. All right? Here's some practice problems. I want you to try these on your own. We'll check them in class, but try those 3 problems that are in your notes packet on your own. Now we're going to look at 30, 60, 90 triangles, 30, 60, 90 right triangles. Okay? On these, there's a different relationship. In a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. Okay? The length of the hypotenuse is twice the length of the shorter leg. The length of the longer leg is square root of 3 times the length of the shorter leg. This relationship exists every time it's 30, 60, 90. So the hypotenuse is 2 times the shorter leg, and the longer leg is square root of 3 times the shorter leg. No problem. Okay? No problem. The chart here, I feel like, is also very useful. Okay? We have the side across from the 30 as 1, the side across from the 60, or the leg across from the 60, square root of 3, and the hypotenuse as 2. And those are always the same. And again, these are 3 equivalent fractions. And I'll show you how we can use those in just on the next page. So right here, first of all, we could just remember it. Okay, so the longer leg is square root of 3 times what? Times the shorter leg, right? So that's 15. Okay, tough to remember it sometimes. I like the chart. So 30, 60, 90, 1, square root of 3, 2. Now, then, and that's going to be the same every time. Then we fill in the blanks with what we have. So across from the 30 is 15. Across from the 60 is x, and across from the 90 is y. Okay? So these are 3 equivalent fractions. So let's do the longer leg first. So 1 over 15 equals square root of 3 over x. Cross multiply, and I get x equals, there's a 15 square roots of 3. Okay, so this is 15 square roots of 3. The hypotenuse, different equation, is just 1 over 15 equals 2 over y. It's just double y. Okay, so we're going to take 2 times 15, and we just get 30. That's all there is to it. What is the value of f in simplest radical form? So, f is the length of the hypotenuse. I can write an equation relating the hypotenuse and the shorter leg of the 30, 60, 90 triangle. The hypotenuse is always 2 times the shorter leg. Okay, 2 times the shorter leg. Here, the shorter leg, so it's 2 times the shorter leg, is 5 times the square root of 3 over 3. So now we just double this. Okay, 2 times 5 is 10. 10 square roots of 3 over 3. And that's it. Is it an ugly number? Sure it is. But who are you to judge? Okay. Find the value of each variable here. In the 30, 60, 90 triangle, the length of the longer leg is square root of 3 times the length of the shorter leg. Okay. So we want to find the longer leg. So the longer leg here is 5. All right. Sorry, we want to find the shorter leg. Okay. So we have the shorter, and again, I think the grid is much more useful. Okay, is much more useful, but we can set it up anyways. We'll set it up the way they have it. That we have, and here, let me just draw the grid to make sure that everybody's on the same page. So 30, 60, 90. This is 1 square root of 3, 2. On this picture, the long leg is what's given. Okay, so that's 5. The shorter leg is s, and the hypotenuse is t. If we can find the shorter leg, we can just double it. Okay, so the shorter leg is going to be, it's going to equal, and if we cross multiply here, we get 5 equals s times the square root of 3. We divide both sides by square root of 3, and we get s equals 5 over square root of 3. Then we have to rationalize our denominator. We multiply both sides by square root of 3, and we get s equals 5 times the square root of 3 over 3. Okay? To find the hypotenuse, we just double it, which is what we did up here. Okay? We just double it. No problem. Speaking of problems, here's some practice ones for you to try. You're going to work on those and check them, and then we'll go over them in class. And here's a lesson check. I want you to try and fill these in, and we'll go over these in class as well. That's it for the notes. Easy stuff. See you guys next time. Bye.